Hello and welcome to the day 1.10 segment and angle addition proofs. This is our day 10 video for unit 1. We talked last time about using algebraic equations to do proofs, and we're still going to be setting up the same kind of proofs, but we can get those equations now by going back to our lesson 7 and lesson 8, where we took a look at segments and those relationships, and also angle relationships, and even going back further beyond that when we talked about segment and angle addition, meaning part plus part equals whole. So we're going to use those concepts today to be able to write some proofs. But the first thing we need to do, and you'll notice on your notes page, the first part of this is that we are looking at some postulates. Now, a postulate in math is a mathematical statement that is true without having to be proven true, like we explained before. And so we've got some of these vocab pieces that we have to put in first because we're going to be using them in the lesson. And so what I'm going to do is, here in just a moment, the video is going to show you all of this filled out, and I'm going to go over it one by one. So while you're watching this video, you're going to want to pause so you can copy these down. But it takes too long in the video for me to write it one little piece at a time, and it's easier for you to just follow along with something I've already written. So when you see these, we're going to go ahead and pause and copy them down and then continue to play and listen to my explanation of these. You can do it one at a time. You can get them all copied down, and then you can continue to watch the video and listen. But either way, we need to make sure you have this information down. So here's what these postulates, and then we have some definitions at the bottom, are really saying to us. All right, so our segment addition postulate simply states if some point B is between two other points, A and C, then the length of AB plus the length of BC has to equal the length of AC. This is no different than part plus part equals whole. Okay? And so that is really all we're doing with this entire page, really, is that part plus part equals whole for these two anyway. And we can abbreviate segment addition postulate as, sorry, that's a G, seg add post, or post. Okay, segment addition postulate. Same idea with angle addition postulate. If I've got an angle where there's a point X in the interior of angle ABC, and it splits it into two parts, then we have this concept that the measure of one angle, ABX, plus the measure of the other angle, XBC, has to equal the whole angle ABC. Again, it's part plus part equals whole for both of these. And we can abbreviate angle addition postulate as angle symbol addition postulate, just like that. Okay? Again, pausing the video here to copy these down is what you really need to do, but make sure you're listening to the explanation after you copy them down. Okay, and then these last two definitions, and we would use definition instead of postulate here because they are, excuse the bell, sorry, they are statements that exist whether we start with the first part or the second part. That works both ways. And so we can use definitions interchangeably like that, depending on the order of our proof that we're going to get to later on. So when we look here at the midpoint definition, this is just the definition of what a midpoint is and how it creates a relationship on a segment. If we know that M is the midpoint of segment AB, then that segment length AM has to equal the other part, MB. Remember, this is our part equals part relationship. Okay? And midpoint definition, we just abbreviate midpoint as MDPT period, and definition is just definition, def. Okay, and this last one is really two definitions in one, but it's the same idea. It just depends on whether you're talking about segments being bisected or angles being bisected. The word bisector means a point, line, segment, or ray that splits the figure into two equal parts. So if it's a segment bisector, if I said line L is a segment bisector, that means that it splits this segment AB into two equal parts, AM equals MB, or we have part equals part, or we have 2 times 1 part equals the whole. Same thing for our angles. If I know that BX is an angle bisector, what that tells me is that the measure of ABX equals the measure of XBC, part equals part, or 2 times the measure of 1 equals the whole thing. Okay, and so that's the definitions and terminology we're going to be using in this lesson. Okay, and so the next part of this video is actually going to go through some examples of proofs using these definitions as well as using equations and pieces that we have worked with in the past. All right, as you turn the page to our examples here, we've got 2 proofs we're going to work on. So this video is going to walk through one at a time. And you'll notice I didn't give you the boxes for your proof. Well, that's okay. We're just going to make a table for our statements and reasons, and it should look like this. Okay, we're just going to go right about here and make a horizontal line, and we're going to split that into 2 equal pieces, or as close to equal as you can. On this side, we are going to write our statements, and on this side, we will write our reasons. Okay, so we're going to make these. Now, I haven't given you the number of blanks or number of steps to use. We're going to follow along as we go and kind of build that in. Sometimes I'll give you those blanks. Sometimes you'll have to kind of do it on your own. All right, but here's what we are given. Okay, this given statement is our starting information. It's our most basic set of information. We're given that J is between H and K. This word, when it says J is between H and K, that means that we are dealing with a segment. Okay, so I want you to know we're not using angles. When you see the word between, we are using a segment. And so it's going to look something like this. And I want you to draw this as we go. We have J being between H and K. So the 2 endpoints of your segment are H and K, and J is somewhere between them. Avoid putting it right in the middle because we are not using the word midpoint. So it doesn't have to be right in the middle. That's why I've offset it closer to one end than the other. And this given information is really important that we put it in a picture because that's going to help as I build my proof. So HK, the entire length, is a length of 100. HJ is the expression x minus 6. And then JK, that expression, I didn't leave a lot of room there, is 2x plus 7. And what we want to prove is that the length of HJ is actually 27. Well, that means I need to build an equation, solve it for my variable, and then plug that variable back into this expression and simplify it to get my final statement of my proof. And so this proof will take a little bit more steps than what you're used to. But we need to draw the picture in when it's not given for us. Okay, so the first thing I want us to do is to number our first statement here. We're going to write our first statement, and that's always the given information. And for now, we do not have to write this part of the given. You can. If you did, I would not count it wrong. But that picture takes care of doing that. We're going to just start with this as our given. And I do want to write all of that again. HK equals 100. HJ equals x minus 6. And JK equals 2x plus 7. If you need to take 2 lines and come down below, that's fine. But the reason I can say all of that is that it is given to me. We should always be able to get the first statement and the word given for your reason. That should be, even if you don't know how to do any of the rest of the proof, I still want you to write that in at least, because that's a starting point. Okay, now what we want to do is be able to set up an equation. I'm going to have you write an extra step in here that if you were just solving a problem on your own, you wouldn't necessarily write this step. But for a proof, I need to know where I'm getting that equation. We are using, in this case, the segment addition postulate because I need to be able to establish that part plus part equals whole relationship. So I'm going to say that HJ plus JK is equal to the total length HK. And the reason for that is because of the segment addition postulate. Now I can use those general terms and plug in my more specific information. instead of hj, I know hj is the expression x minus 6. Instead of jk, I know it's the expression 2x plus 7. And instead of the entire whole thing hk, I know I should use 100. Well, what did we do here? We took these values out and replaced them with equivalent values. What we're using is substitution, the substitution property of equality. If you choose to write POE after that, that's okay. That part is actually optional for substitution, because that's the only substitution property we have. And now I can start to solve my equation just like we did in the last lesson, in lesson 9. First thing we want to do is combine our like terms. X plus 2x is 3x. Negative 6 plus 7 is 1, so that's a positive 1. And that equals 100. And all we did here was combine like terms. You can write combine like terms. Or you can write the word simplify. And now we go through our process of solving the equation. Subtracting 1 from both sides turns the equation into 3x equals 99. And since we subtracted 1 from both sides, that's the subtraction property of equality. We do have to write POE there. And then, to get x by itself, we would divide both sides by 3. 99 divided by 3 is 33. And since I got this by dividing both sides by 9, that's the division, by 3. It's the division property of equality. But we're not done. That's not what I'm trying to prove. I'm trying to prove hj equals 27. So what I'm going to do now, I'm going to go back to my hj expression that I've used in my given. I'm going to write hj equals, but instead of writing x minus 6, I'm going to write 33 minus 6. Once again, we took out the variable x and we put in 33. That's always substitution. There's only one more step to get to that, and that's just to simplify this. 33 minus 6 is 27, so I need to finish my proof by saying hj equals 27, and all we did was simplify. Okay, when you just do subtraction or addition on one side of the equal sign and you just make a problem like this into its final answer, that's just simplifying. Okay, so that's how we do a proof. All right, we've got one more example. I'm going to go through the beginning parts of this, and then I'm going to have you try and finish it on your own. Okay, I'm actually going to pause the video, and I'm going to fill in some information to save some video time, so you'll need to pause it and copy it down. But when we set up this example, it should look like this to start. Okay, we want to draw out our segment. E is the midpoint of DF, so it is in the middle, and we can mark the two parts congruent. And then they tell you DE is x plus 20, and EF is 5x minus 4. We're still going to start off our given statement. I'm actually putting all of the givens in because that word midpoint is very important for how I set up my equation. We're actually going to use the definition of midpoint now. Okay, if you go back to the front and look at the definition of midpoint, to set up an equation like this, that the two parts are equal, because that's the two expressions I've been given. So I want to say DE equals EF, and my reason is the midpoint definition. Okay, and then from there I can substitute in and get my equation. Instead of DE, I want to use x plus 20. And instead of EF, I want to have 5x minus 4. And the reason, again, is substitution, because I plugged in equivalent values or equivalent expressions for those labels. Now, from this point, we're just solving the equation. This goes back to the previous lesson, and don't forget at the end, the last few steps here took us from what our x value equals to plugging it back in to getting what we're trying to prove. We're going to do the same thing here. So this is going to take a few more steps. I want you guys to go through and solve this and bring your answers to class, and we will talk about those together.